Yo, what is up, math warriors? Welcome back to the only classroom where limits break and your brains grow. If this is your first time, buckle up. If you were here last time, you're just chilling with some baby derivatives. We're gonna get into it good this time. But today's topic will mainly be about end behavior. Okay, so picture this. You're watching a movie and you're wondering how it ends. That's end behavior. But in math, it's just a different context. End behavior is all about what a function does way out the edges as x gets super huge or as x gets super negative. It tells us the long-term trend of the function. So let's look at common notation. The limit as x goes to infinity of f of x. All this notation means is that as x approaches infinity, or whatever number they put in there, what will the function f of x do? In other words, what is the limit of the function? So let's look at the problem. Limit as x goes to infinity of 3x to the fourth minus 5x squared plus 2. When x goes to infinity, what happens? So, in this case, you might be looking and seeing, okay, well, there's 3x to the fourth minus 5x squared plus 2. How am I supposed to calculate that? Everything is so hard. I hate math, right? No, you don't hate math, right? So what you do, you just look at the number with the highest degree. So in this case, or you look at the term with the highest degree. So in this case, it's 3x to the fourth. This is the big dog, the BD. And you only care about the big dog. You don't care about these little dogs. You don't care about that prey. You care about the big dog. So what do? You just pretend the little dogs don't even exist. So now as x gets increasingly big to infinity, 3x to the fourth also gets increasingly big, also to infinity. So the limit of 3x to the fourth power as x approaches infinity will just be infinity. So focus on the highest degree term and it'll tell you the end behavior. Let's do another example with a fraction. Let's say we have the limit as x approaches infinity of 2x cubed plus 5x minus 1 over x cubed. Let's do x cubed minus x plus 4. So here, if you remember, you have to look at the leading term, or look at the degree that is the highest. So take a few seconds, try to solve this on your own. But if you can't, I'll be here. Now, to get started with this, you focus only on the highest degree terms. In this case, it is going to be 2x cubed over x cubed. Now, since both of the degrees are the same, what can you do with this fraction? Well, you could just cancel out x cubed, and you can cancel out x cubed. So this will equal to 2. You might be thinking, is that really it? Yes, that is really it. The limit of this function as x approaches infinity is just 2, because the leading terms, 2x cubed and x cubed, will just cancel each other out. And the 2 is the only thing that's left. So, what this means is that even as x approaches negative infinity, it will still be 2. So let's have this other problem. Let's say we have 4x squared minus 7x over x cubed plus 2. And the limit as x approaches infinity. So we see that the highest degree in the numerator is 4x squared, and the highest degree in the denominator is x cubed. So this is just the general rule for any time that the degree on the bottom is bigger than the degree on the top. This will equal to 0. And if you remember my previous videos, this is actually an asymptote. Isn't it cool how these two math sections just connect together? I think it is. But yeah, that's what happens. So as x approaches infinity, again, if it approaches positive or negative infinity, doesn't matter. The limit will be 0. Let's do another one. Let's say we have x to the 4th plus 3x squared minus 8 over 5x to the 4th minus 2x plus 9. Take some time to do this on your own, but let's get started if you're still here. So, the degree on top, 4. Degree on bottom, 4. What happens? Cancels each other out. What happens now? 1/5. What is the limit? The limit of this function is equal to 1/5 as x approaches infinity. And actually positive or negative infinity. Now here is actually a tricky question. We have the limit as x approaches infinity of sine x plus 3x over x. So you might stumble on this problem because you don't really know what to do, but that's okay. Just break it down to pieces. Sine of x, as x approaches infinity, if you know your trigonometric functions, you know sine doesn't really approach anything. It just bounces around from -1 to 1 and all the numbers in between. And this means that the function diverges. But, so we have sine of x bouncing around -1 and 1, right? So we have sine of x here. Then we have 3 of x, or 3x. What does 3x do as x goes to infinity? Well, 3x also goes to infinity. It gets insanely huge. So 3x just grows. And then we divide everything by x. But since sine of x is just equal to 1 or -1, or any numbers in between, the function will just be about 3x over x. And this whole thing will just become 3. Because of the large numbers here, we don't have to care about this 1 or the -1 or whatever the small numbers here in sine of x are. Because infinity plus 1 is still infinity. Infinity minus 1 is still infinity. So it's just going to be 3 of x over x, which just equals to 3. Now from the previous video, people have been telling me I should use harder examples and examples that include trigonometric functions. So let's do that here. Let's say we have x squared times cos x, and we want to differentiate this. Since the general rule is just the first function times the derivative of the second function plus the second function times the derivative of the first function, what this will be is x squared times the derivative of cos x, which is negative sine, plus the second function, cos x, times the derivative of the first function, which is 2x. So this will be negative x squared sine x plus 2x cos x. Now another one. Say we have x cubed times tan x. So if we want to differentiate this, we'll have x cubed times the derivative of tan x, which is sec squared x. And if you don't know these properties of these trigonometric functions, you can go to my previous videos because I talk about how the derivatives of cos and sine and secant and tangent So it'll be x cubed sec squared x, then plus tan x, I forgot the n here, times 3x squared. Okay, now let's do a chain rule problem. Let's say we have the sine of x squared, right? And we want to differentiate this. So what do? Since this is chain rule, we remember that we take the derivative of the inside function and multiply that by the derivative of the outside function. So if you remember my rant in my previous videos, your first step should always be to just look at the outside function. Now don't touch the derivative or anything inside. Just differentiate the outside function. Derivative of sine is going to be cosine. And then just plug in what we have inside here, x squared. Now you may look at the inside function, which is x squared, and take the derivative of that, which is 2x. The number one mistake that students make is taking the derivative of the inside and the outside all at once. But all you do is just take the derivative of the outside function, keep the inside function the same, then multiply that by the derivative of the inside function. So that's how chain rule would look like in a trigonometric context. So what do we even just do? So end behavior can tell you where the graph is heading when x goes off the rails. If we're given some function, we're able to know what it acts like as x approaches infinity or negative infinity. And just remember to ignore the small terms. Look for the power players. Look for the big terms, the big dogs. Just remember, BD, that's what you're looking for. You're looking for the big dogs. And when trigonometry tags along, kind of treat it like a background noise unless it's multiplied, then you pay attention. Because like for sine, we didn't really need to pay attention to it because it just bounced around -1 and 1. Now product rule, you'll see it everywhere, even with trigonometric functions, and it's just the same rules. Chain rule is the inception of derivatives. And knowing end behavior is useful for a ton of things in real life because it allows you to find out how things act as the properties go to infinity, which is especially useful in computer science, physics, and even economics. So remember, guys, math doesn't care about your feelings, but I do. You've got this. Breathe. Take a snack break. Come back stronger. And I'll catch you next time for some math mayhem. Now, on to explaining what this means. So here we have the limit as x goes to infinity. And this is the end behavior of a function. So as you can see here, some miscreant put lead into the battery of a computer, which caused some smoke to appear. Now the limit of this action, as you keep on repeating this action instead of doing your classwork, is going to be ending up at McDonald's. So take that what you will. Thank you guys. I'll see you in the next one. Peace.